Are you ready for some factoring fun? Let's go. Okay, there are several tricks that we're going to be talking about today. Always, number one, take out the GCF, greatest common factor. And then, based on the type, that will help you know how else to factor this. This will be up on the board during the test. However, the formulas for how to actually factor those need to be in your brain. All right, so let's decide. First, is there a GCF? Yes, there is. It's 5. I'm going to take out 5. And I'm left with each of these 3 terms divided by 5. So 5r squared divided by 5 is r squared. 35r divided by 5 is 7r. Negative 40 divided by 5 is negative 8. Now, what do I have? I have a trinomial where a, the number in front of the squared term, is 1. It was 5, but since we took out the GCF, that makes our life so much easier. So when a is equal to 1, we can use the P's and Q's method. I have not figured this thing out yet. Okay, 2 things that multiply to give you C and add to give you B. So 2 numbers that multiply to give you C, which is negative 8, and those exact same numbers need to add to give you positive 7. So we have R, and then those 2 numbers have to be 7 and 8, 8 and 1, not 7 and 8, 8 and 1. All right, 8 and 1, 8 and 1. How are we going to get a positive 7? The 8 is going to be positive. The bigger number is going to be positive. Plus 8 and minus. Our 1 has to be minus. Okay, so just to check, positive 8 times negative 1 is negative 8. Positive 8 minus 1 is positive 7. Awesome. All right, let's do number 2. Okay, so GCF, n. Ooh, n squared. Okay, so n squared times n squared is n to the 4th, minus 8n to the 1, minus 20 times n squared. Okay, perfect. So now we have a trinomial. A is 1, so we factor with the P's and Q's. Two things need to multiply to be negative 20 and add or subtract to give me negative 8. Those 2 numbers to multiply to give you a negative, one of them is positive and one of them has to be negative. Okay, so we already know one is positive and one is negative. And so 10 and 2 looks like the best options for me, to me. The bigger number is going to be negative because the 8 is negative, so 10, negative 10, and positive 2. So to completely factor n and n plus 2 minus 10. Check just to make sure there's nothing else you can factor. Okay, and you're good to go. Number 5. First of all, is there a GCF? Ooh, 7 goes into the first 2 numbers, and this one, but it doesn't go into 10. Okay, so no, does not look like there's a GCF. The type is the only one with 4 terms, and we factor by grouping. Factor by grouping, you just throw those parentheses on and factor out the GCF from only 2 terms each. Okay, so from the first 2, what is the GCF? 7x squared. And what am I left with? 2x. 7x squared times 2x is 14x cubed plus 7. Great. Okay, now, in the next pieces, negative 10x minus 35. Okay, this is the next group. This does not mean multiply. No. This is the next group of terms that I factored out the GCF for. Okay, so I factor out negative 5. Always factor out the negative. If there is a negative here, it should be here. Negative 5 times 2x plus 7. And this is where you'll want to put minus because you'll want to just drop down the sign. But since you factored out a negative, negative 5 times positive 7 gives me negative 35. Ding, ding, ding. We have a common factor. So right here you have a term. And what's common between those two is this. So we write it one time, and we're left with 7x squared and negative 5. Check for perfect squares or perfect cubes. Nope, we're done. Let's do number 6. GCF. Is there a GCF? Well, 5 goes in, 5 goes in, 5 goes in. Nope, sad. Okay, so 4 terms. How do we do that? Grouping. Just the first two. What's the GCF? 5n squared. And then I had 5n plus 3. And then from here, taking out the common factor, 7, and make sure you drop this sign. Have to do that. Negative 7. And that gives me 5n. Negative 7 times what gives me negative 21? Positive 3. All right. Again, common factor. Sweet. 5n plus 3, parentheses, 5n squared minus 7. If they're not the same, then you can't go further than that. But always check for perfect squares, because oftentimes you'll get a perfect squares thing out of this, and then you'll stop, and you'll get marked off if you don't complete that. So if one of these is perfect squares, you have to go one more step and do the a plus b, a minus b. Speaking of perfect squares, let's take a look at number 10. All right, so what I notice is that 9 and 16 are both perfect squares. N squared, anything variable to any even power, is a perfect square. So this is in the form a squared minus b squared, okay, where that factors to be a plus b, a minus b. So a would be the square root of a squared, so take the square root of your first term, and that's going to go in the front, so 3n times 3n, and take the square root of your last term, which is plus or minus 4, so positive 4 and negative 4. Check to make sure there's nothing else you can do. Nope. Good to go. Number 14. This is some weird looking stuff. 432 and 2 and... Okay, guess what? This little m to the 3 gives me a hint. This is probably perfect cubes. Okay? And it's really easy to get points for perfect cubes if you have the formula memorized, and it's virtually impossible to do it without knowing the formula. So please, please, please make sure you know it by heart before our test on Thursday. But first, always take out the GCF. That's 2. Now, is 216 a perfect cube? Yes, it is. 216 is actually 6 times 6 times 6. 6 cubed is 216. Okay. So sum or difference of cubes. So 2 terms means difference of perfect squares or sum or difference of cubes. Okay, and this is a difference because it's subtraction of cubes. So difference of cubes. This formula goes as follows. A cubed minus B cubed turns into A minus B times this trinomial. Now, when you take out the 2, you see these parentheses. That does not mean you just throw on the next parentheses. No, this is the first step. That's the GCF step. We have not even gotten into this. In fact, if we hadn't taken out 2, we couldn't have even factored this with, these are not perfect cubes. So it has to be perfect cubes before we can actually factor, before we can say, okay, now I'm taking my perfect cubes and I'm putting them into a binomial times a trinomial, because that's how I know they actually factor. Drop down that 2 in the front. Okay, first term right here is the cubed root. So cubed root of m cubed is m. The cubed root of 216 is 6. Drop your sign. There is always 1 minus 2 plus. So 1 minus 2 plus, 1 minus 2 plus, 1 minus 2 plus. All right, so these are going to be plus signs. Don't let the sign of the 6 or whatever change anything. The signs are always the same. They're fixed, always 1 minus 2 plus. So the first term is this squared, so m squared. The last term is this squared, so 36. And the middle term is this, 6 times m, so 6m. There is no more factoring that you